Hi guys, in this video lesson we're going to be reviewing simplifying square roots and cubed roots. I believe you did at least a little bit of this last year in geometry, but based on some of the questions I've gotten so far this year, I thought it might be a good idea to review this before we move on to a point where we're going to be using it every day. So first of all, before we get into how to simplify them, it's important for us to think about what a perfect square and a perfect square root actually are. So, when we're talking about a perfect square and a square root, a perfect square is any integer squared. So, 1 squared is 1 because 1 times 1 is 1. 2 squared is 4 because 2 times 2 is 4. 3 squared is 9 because 3 times 3 is 9. 4 squared is 16 because 4 times 4 is 16. 5 times 5 is 25 because, 5 squared is 25 because 5 times 5 is 25. 6 squared is 36. 7 squared is 49. 64. 81. 100. 121. 144. And then sometimes you'll see 13 squared, which is 169. Other numbers come up from time to time, 15 squared or 20 squared, but these are the general ones that you kind of want to have in that knowledge bank in your brain. It makes simplifying so much easier if you know what your options are. You can use this as reference from time to time, but it's really going to slow down the process if you're always having to rewrite this list. So why is it important to know our perfect squares? It's important to know our perfect squares in order to simplify a square root. So, for instance, if I want to know what radical 27 breaks down into, I need to figure out what the biggest perfect square is that divides evenly into 27. In other words, I need to figure out what factor of 27 is a perfect square, and not just which one's a factor, but what's the biggest factor of 27 that's a perfect square. So if you're thinking about that list, and in fact, let's just go back here and I'm going to cut and paste it for what we're doing for pointing purposes. Just going to put it up here for reference. So the biggest one of these numbers that divides evenly into 27 is 9. And sometimes kids will put 25 because it's smaller than 27, but 25 does not divide evenly into 27. So when I go to rewrite this, I'm going to say, well, 9 goes into 27 3 times. And I know the square root of 9 is 3, but I don't know the square root of 3. Somewhere between 1 and 2 because radical 1 is 1 and radical 4 is 2. But the decimal approximation isn't helpful in this instance because the goal here is we're simplifying square roots when we want an exact answer, something with precision. So if you look at example 2, certainly 121 is less than 125, but it doesn't divide evenly into 125. 25 divides evenly into 125. So we can say, well, 125 is 25 times 5. And I know the square root of 25 is 5. And I don't know the square root of 5. So I just leave it a radical 5. I leave it in exact form. And this next one, it's going to work the same way. You're going to leave 9 in front as a coefficient. And then you're going to use this list and say, what's the biggest one of these numbers that divides evenly into 44? So I know 4 times 11 is 44. And then I'm going to go down here. The square root of 4 is 2. And 9 times 2 is 18. Take a minute and see if you can do these try it questions. So I'm going to put this back over here just so we can use it as a reference. So the largest one of these that divides evenly into 48 is 16. And 16 times 3 is 48. I don't know the square root of 3, but I know the square root of 16 is 4. 100 goes into 500 5 times. And I know the square root of 100 is 10. So the last one has the most writing. We're going to say 7. And this is one that may not have been one you knew off the top of your head or you could easily see. So you could start with 144 and just start dividing and see which one of these divides evenly into 405. You may have noticed, well, 100's not going to divide in there evenly, but maybe you didn't know about 144 or 121. Nothing wrong with checking that if you're uncertain. 81, however, divides evenly into 405 because 81 times 5 is 405. So break it down. So I get 7 times 9 times radical 5, and I know 7 times 9 is 63. Okay, so something to notice with all of these, we never took the square root of a negative number. That comes later. Square root of even, well, let me rephrase that. Not just a square root, any even root, if you take a negative, that's not in the real set of numbers. So all of these were positive values under the radicand. However, with cubes, it's a little different. So I'm going to go ahead and give you these perfect cubes, and then I'm going to give you an example of why. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1,000, 11 cubed is 1,331, and 12 cubed is 1,728. Now, if you're thinking to yourself, I'm never going to remember all these. Well, first of all, perfect squares are much more important than perfect cubes. Second of all, when it comes to perfect cubes, generally speaking, most of the time when we're simplifying, we're looking at somewhere between a base of 1 and 6 and maybe a base of 10 from time to time. But generally, it's more of those smaller values. And more importantly for you in this course is perfect squares you'll use all year, and perfect cubes show up from time to time, but they're much less common. So part of what makes a perfect cube unique is if I were to multiply 2 times 2, I get 4. And if I were to multiply -2 times -2, I also get positive 4. But with a perfect cube, since you're multiplying 3 times, if I were to multiply 2 times 2 times 2, I certainly get 8. But if I were to multiply -2 times -2 times -2, I get -8. So when we have this odd power, or when we're taking the odd root of something, you're going to be working with negatives in this instance where you weren't before. So let's look at some examples. And let me do that screenshot again, just so we have a reference point. So just like we did previously, you're going to look through this list and say which is the largest one of these numbers that divides evenly into 375. And yes, 343 is smaller, but it doesn't divide evenly into 375. So you're going to break it down as the cubed root of 125 times 3. So the cubed root of 125 times the cubed root of 3. I know the cubed root of 125 is 5 because 5 times 5 times 5 is 125. But I don't know the cubed root of 3. It's a decimal. It's not clean. It's not something that's worth memorizing. So this is my final answer. On this next example, if I look at my list, I have far less to choose from because there's only 3 numbers that are even less than 56. But I know that 8 times 7 is 56, so I can rewrite this as the cubed root of negative 8 times 7. And I know negative 2 times negative 2 times negative 2 is negative 8. So when I break this down, I'm going to say, well, the cubed root of negative 8 is negative 2, and then the cubed root of 7. In example 3, it works like the other ones where you kind of ignore the coefficient of 5 to start and then incorporate it more at the end. So in this problem, you would need to know what divides into 320. And again, this is one of those ones that may not be as familiar for you. So you could sit here and divide 320 by 216, or 320 divided by 125, 320 divided by 64. And when you get to that point, you'll see that 64 goes in there 5 times. Now, yes, I am showing more work than you probably are used to showing. But again, if this is a reteach, this is to make sure that it's ingrained in your brain why and how you follow this process. If you can skip some steps, good for you. But this is really the process that makes this simplifying mathematically sound. Okay, just like we did before, take a few minutes yourself and try these 3 problems. I'm going to leave this off to the side, and let's go through these answers. So if we're looking at 108, the largest one of these that divides evenly into 108 is 27. And 27 goes in there 4 times. I know the cubed root of 27 is 3, so it's 3 cubed root of 4. This next one, the largest one of these that divides evenly into 3,000 is 1,000. So I'm going to break it down into the cubed root of negative 1,000 times the cubed root of 3. So I get negative 10 cubed root of 3. Last one. Ignore this coefficient of 4 for a second. I'm going to find the largest perfect cube that divides evenly into 1024 is 512. And that's 512 times 2. And I can see that the cubed root of 512 is 8, so I get 4 times 8 times the cubed root of 2. And 4 times 8 is 32. And on Monday, when you get to class, you're going to be using this to complete the assignment. And you're going to be using this process all throughout the year, mostly with perfect squares. But feel free to rewatch this puzzle as many times as you need or want. I expect that you were able to get at least 60% correct on this. That's kind of your goal in any ed puzzle you do.